Hello, my name is Nico Palestra and I'm a Director of Solution Engineering here at Gravitee, and I'm based in London. In this video today, I will be showing you how you can apply API management capabilities and practices to also event-driven APIs. So without further ado, let's get started. Okay, so let's start first of all in trying to understand what is driving the event-driven architecture adoption. Three main areas we can identify. First of all, a growth in microservices. So the need to break down the monolith and work on small single functionalities, which are focused on delivering a specific function or specific data. There's also a big adoption of real-time and just-in-time decision-making. Think about, for example, the ability to see trains in real time, train schedules in real time. Also think about, for example, that 1 millisecond in a financial trading setting is worth $8 million. And finally, a big push to decouple concern. So basically splitting apart point-to-point integrations in order for device A not necessarily need to know where device B is or whether device B, for example, has changed. But let's stop for a second and let's try to answer this question. What are event-driven architecture anyway? So let's introduce this concept with a very simple example, which you're probably familiar with. Let's assume you are using your favorite taxi service application. You would use your mobile phone to send your location and request a taxi. You will then receive a notification that your booking is confirmed and that the taxi is due to arrive soon. So let's see how this works in a world without events. And let's focus on the first part of this use case. User actually booking a taxi, and let's ignore for now the driver location request. Normally when you book a taxi, the taxi won't be ready straight away. A driver will need to pick up your request and accept it. So what would happen in a request response world? So the user would send a request for a taxi. You can see on the screen, for example, an HTTP post to a taxi booking endpoint. And the taxi would just reply back with something that says, okay, we got your request, but the driver is not ready yet. So what do you do now at this point? Essentially, you keep chasing. So your mobile application will keep sending requests to understand whether the booking is now complete. So normally what happens is you would send a GET request to an endpoint, which is the endpoint you received when the booking was created, until that endpoint returns something which says, actually, the booking is now complete. So the taxi driver probably has picked up the request. So a record has been created in a sort of database. And finally, the request will return with a 200 OK and some details around the booking, the driver name, and so on. Now, as you can imagine, this is not ideal, and it creates what's called the polling madness. So what are the issues with polling madness? First of all, it wastes resources because each HTTP request requires a new connection to be established, SSL handshake, possibly a certificate exchange if mutual TLS is in place. Also, customers might be on a, for example, meter connection. Imagine if you are abroad, for example. So this will actually cost money to the end user. This approach also is not really real time. There might be a few seconds between each request, and depending on the context, this could be less than ideal. Just think about this, as I mentioned before, that 1 millisecond in the context of financial trading can cost, again, $8 million. So imagine what could happen in 2 or 3 seconds between each request. And finally, but I'm sure there is more, this makes it impossible to leverage usual capabilities of an API management solution to protect your backend or monetize your API. Policies, for example, like rate limiting and quota, don't make any sense when the number of calls is not strictly related to the number of business transactions. So how do we solve this problem of real-time messaging? Well, the answer is event-driven architecture. An event-driven architecture uses events to trigger and communicate between decoupled services. And is common in modern applications built with microservices. An event is a change in state or an update, like, for example, an interest shown in booking a taxi. In an event-driven architecture, you typically have a publisher, and also consumers of these events. Publishers are components in the architecture that generally obviously publish new messages or events. These are then distributed to a message or event broker or router, which process the messages. For example, makes validation, filter the messages, potentially transform these messages, and then places these messages into a channel. At this point, one or more consumers who are interested to the messages flowing into the channel will receive the messages in near real time. The beauty of this architecture is that it is completely decoupled. The publisher doesn't know who the consumers are, and even whether there is any consumer at all. You can keep adding consumers or publishers without making any change to the respective publisher or consumer. So now, armed with this new knowledge, let's see how we could design our taxi booking system. When the customer needs to book a taxi, this time instead of sending a request directly to the taxi service, the mobile app will actually publish a new message to notify the interest in booking a taxi. The taxi will then subscribe to messages related to an interest to book any taxi. And when a new request comes in, i.e. An event is actually published on the message broker, the taxi service will receive it. And once a taxi has been booked, for example, a taxi driver accepts the journey, a message is sent back to the mobile application. This all happens in real time without the client needing to constantly poll for whether the taxi has been booked or not. Now the question is, this looks very complicated. I'm a mobile or web app developer. I don't necessarily want or need to know the complexity of the message broker. Also, what if we change completely the underlying architecture? Maybe move, for example, from Kafka to RabbitMQ. How do we minimize the blast radius of such a change without impacting the user experience? But also, how do we enable real-time user experience? So how do we enable everyone to leverage this new approach, this new architecture? So welcome to event-driven APIs. Event-driven APIs allow applications to react in real time, or at least near real time, to certain events or messages being produced, so to provide a better user experience. So let's start talking about event-driven APIs by mentioning what are the most common ones in use today. In order of popularity, we have WebSockets, webhooks, and server-sent events. We also have GraphQL subscriptions, which are popular, but they're not as popular as the first three. So how do you enable real-time user experiences? But also, how do you allow a web developer, for example, to leverage this new architecture? Welcome to the event-driven APIs. Event-driven APIs allow applications to react in real time, or at least near real time, to certain events or messages being produced, so to provide a better user experience. So let's start talking about event-driven APIs by mentioning what are the most common ones in use today. First of all, we have WebSockets. WebSockets allow our clients to establish a persistent connection with a service, which allow real-time two-way event streaming. We then have server-sent events, which allow servers to send events back to the client in a kind of monodirectional fashion. And finally, we have webhooks, also called reversed API, which allow clients to subscribe to certain events by providing a callback URL, where typically the service will post events as soon as they happen. I'm also mentioning here GraphQL subscriptions. GraphQL subscriptions allow a consumer to subscribe to certain queries so that when the underlying data changes, the data provider will push the new data in the exact format as it was requested. I won't be exploring GraphQL much in this slide since this is not very popular yet. So let's start with WebSockets, and let's analyze how our taxi booking use case can be made real-time using a WebSocket event-driven API. To start with, you will typically need an API gateway exposing the WebSocket. Adopting an API gateway brings many advantages, but we'll touch on this later. So we have our consumer who needs a taxi, and she will click on a button on the web application to say, I want to book a taxi. This will initiate a WebSocket connection with the API gateway, and the app will send a message via the WebSocket. Now, depending on the message broker and the API gateway capabilities, this can result in a message pushed to a queue, for example, on a stream, on a topic, etc. On the other side, as already shown, a taxi service will be listening, will be consuming those messages. And once the taxi driver has accepted, a notification or a message or event will be sent back to the application. It's important to know that in all this time, the mobile app has its WebSocket connection established with the API gateway. This allows messages to flow back and forth as they are produced. The same WebSocket can also be used by the taxi to stream, for example, back its location. Or it could be used by the mobile app to send a notification to have the trip cancelled. Now let's zoom in the API gateway to see what really happens and what value an API gateway really brings into this picture. After the user clicks on the button to book a taxi, an HTTP request is sent to the API gateway. This request will be done using a WebSocket or a secure WebSocket URI protocol, and will contain certain headers that will instruct the API gateway to keep the connection open, but also to upgrade it to something else. In our case, it's going to be a WebSocket. The gateway will respond with an HTTP status 100 and upgrade WebSocket header. This will initiate a full duplex connection between the mobile application and the API gateway. Full duplex means that both the client and the server can send and receive messages across the same connection, same channel. Now you might be wondering, what is the API gateway really doing here? Well, while the mobile app is essentially talking HTTP, the API gateway will transform the WebSocket frames into TCP packets, which are understood by the specific message broker being utilized. Obviously, this strictly depends on the API gateway capabilities. Later, I will show you how Gravitee allows you to do exactly that. Once the mobile application is done, for example, the user closes the app or maybe decides to cancel the trip, it will close the connection. So that obviously no new messages will be sent back to the application. So hopefully this starts show you the advantage of adopting an API gateway layer. This will essentially hide the complexity of whatever message broker is in use, making your application future-proof and also easy to embed into an event-driven architecture. So now that we explain WebSockets, let's have a look at how server-sent events actually work. Let's assume the mobile app wants just to know where the taxi is. The mobile app will send a request to the API gateway with a request to connect to a server that will stream events. The client will do this by creating an event source object. It will then wait for the response with a stream of event messages. At this point, the server leaves the HTTP response open until it has no more events to send. The server will terminate a stale connection if the connection has been open long enough, or wait for the client to explicitly close the initial request. Once again, we see the API gateway playing the role of a protocol mediator. The main limitation of a server-side event is the ability for a client to pass information to a server. So basically, this is a one-way conversation between the server and the client, not the other way around. Server-sent events have several advantages. For example, it's transported over simple HTTP instead of a custom protocol, can be polyfilled with JavaScript to backport a server-sent event to browsers that do not support it yet. It has built-in support for reconnection and also event ID. It's normally very easy to use in a situation where a corporate firewall might be doing packet inspection. It's also useful for apps for applications that enable one-way communication of data. For example, think about a livestock prices where all your application is doing is to look at the real-time prices without the ability to really do anything with those prices. However, server-side event also has some stumbling blocks, some disadvantages. First of all, it's limited to UTF-8. It doesn't support binary data. It's also limited for the number of maximum connections that a single browser can have open. And this is painful, for example, when you start opening different tabs which are using server-side event. And obviously, server-side event is also monodirectional, so it doesn't work for use cases where the client also needs to send messages back to the server. Now, I've shown you a lot of things, and you could now expose all these fancy APIs to your client applications or potentially to third parties or business partners. The question now is, how do you document all these APIs? How do you make channels, messages, and endpoints discoverable? How do you enforce governance to ensure best practices and common standards are used and also reused? How do you secure access to it? And how do you protect your services? And finally, how do you monitor the performance, prevent abuse, and determine who is accessing what? Well, you guessed it, an API management solution will be the answer here. So what does an API management have to offer to an event-driven architecture? Well, there are different areas where an API management becomes really useful. First of all, security. So what does an API management have to offer to an event-driven architecture? Well, first of all, security. An API management solution would allow you to apply all the same security practices you're already familiar with REST APIs. For example, you would be able to apply an IDP or to apply O2 authentication to your asynchronous API. It will allow you to protect your backend with policies like throttling, rate limiting, caching, and so on. An API management solution can also be used to document your API, to publish, for example, a sync and REST API specification within the same portal. It allows you to monitor the health of your APIs. And finally, provides the full lifecycle management with, for example, versioning, stopping and starting an API, and so on. So now that we introduced the concept of event-driven APIs, let's have a look at what does an API lifecycle looks like. You ideally want to start with the design. This will allow you to fail fast and also receive early validation and feedback. Once you have the design contract in place, this will allow you to do a few things. For example, you could use the contract for code generation, or depending on what you're building, you could even use the contract to mock data to start building client applications while consumers and producers are being built. In the meantime, you or maybe a platform owner can secure and start managing your API by applying, for example, message filtering, message transformation, traffic shaping, and so on. Making sure the API is monitored is essential before the API is deployed to production. This includes setting up monitoring dashboards, alerts, and so on. And finally, APIs should be published to an API portal so they are discoverable and consumable by other developers within the organization or even by third parties. You want all these capabilities to be provided by a single platform in order to reduce toil and cost, number of tools to manage, the skills also you need to learn, and also to leverage the seamless integration across all the area of the platform. Otherwise, the risk is you will need to integrate the integration platform. Gravitee is a fully open source API management and access management platform that provides all the API management capabilities together with access management capabilities in a single and unified platform. Normally, we see 4 main actors playing an important role in the management of the APIs. App developers, they will typically leverage the developer portal to discover existing APIs, read the documentation, maybe try the API on a sandbox, and finally subscribe to start using the API. Then we have API owners and potentially CI/CD pipelines for organizations who want to automate their entire API lifecycle. They will typically manage the API leveraging Gravitee API Console and also the Flow Designer to apply security, message transformation, to monitor the API performance, and etc. And once the API has been hardened, it will be ready to be deployed on an API gateway. Finally, obviously, we will have client applications, like, for example, a mobile application, web app, microservices, and so on. This will involve REST API, SOAP web services, established WebSocket connectivity with the API gateway, which in turn will apply security and other policies. When speaking about event-driven API, the management flow doesn't really change. And that's the beauty of adopting an API management platform like Gravitee, which supports event-driven API as well as RESTful APIs. Not to mention the fact that typically applications both adopt asynchronous and synchronous patterns, which will potentially require different management platforms. So you will still have developers leveraging the portal to discover and consume those APIs. The API owners will manage the API using the console exactly as they already did with their RESTful APIs. And once ready, the API will be deployed on the gateway, ready to be consumed. Now, an application, let's say a mobile application, interested in consuming an event-driven API, will connect via WebSockets, single server-sent event, webhooks, and so on to the API gateway. That will enable the application to react in real time when a taxi, for example, is ready, when it's coming, or when, for example, it's just moving. The API manager will provide the exact same capabilities provided by to the RESTful APIs. It will provide security, so an application developer will be able to invoke the event-driven API by providing, for example, an API key. It will provide monitoring capabilities to measure how these APIs are being used, the performance, who is leveraging the API in order to potentially change the commercial model around those APIs. The API manager will also provide message filtering and transformation capabilities on top of the native capabilities provided by Message Broker. Now you can notice there is an empty space. That is Gravitee Service Management Ecosystem. Gravitee Services Management Ecosystem provides a connector framework that allows our API gateway to perform protocol mediation and translate an HTTP connectivity into whatever protocol or message format a message broker might require, whether it's HTTP to TCP, HTTP to JMS, HTTP to gRPC, and so on. The next question we want to ask and answer is, how do you describe an event-driven API? Well, probably you heard of the async spec. The async API specification is an initiative to improve the current state of the event-driven APIs, to provide some sort of standard around how these APIs should be documented. It makes working with event-driven APIs as easy as it is with RESTful APIs. You will see in a later section that the asynchronous API follows the same approach of the Open API specification. In fact, they share loads of structure in common. In fact, let's look at a snippet. Probably if you are familiar with the RESTful APIs and with Open API specification, this will certainly look very familiar to you. In fact, as I already mentioned, async spec and Open API specification, they share loads of aspects. They have loads of aspects in common. So as you can see here, a path in Open API specification relates to a channel in async spec. A path item corresponds to a channel item. So loads of the concept already specified and present in Open API specification have been also used in async spec. So your time to learn async spec will be extremely low. So this brings us to the end of this video. And I just want to recap with some takeaways. So we learned how event-driven APIs allow developers to deliver consumers a better user experience. We also shown how there are different ways events and messages can be consumed and produced. So we talked about server-sent events, WebSockets, webhooks, and so on. I mentioned how API gateways helps with abstracting the message broker complexity, which allows you, for example, to change your architecture without breaking the user experience. And finally, an API manager reduces the effort in managing the event-driven API software lifecycle, pretty much harmonizing and unifying the experience of managing event-driven APIs and RESTful APIs in a single unified platform. So if you want to find out more about Gravitee, you can join our community so you can ask any question or see what other people are asking. You can also request a demo, or since Gravitee is an open source solution at core, you can head on our GitHub website, GitHub repository, to have a look at our website and potentially install Gravitee on your laptop. For any question, you can reach out to me directly. Thank you and have a wonderful day.